Good evening. This is W2NDG for the OMARC Sunday Night Science and Technology Net. Now, first, we're going to pause and see if there's any emergency traffic. Nothing heard, which is always a good thing. So I said, this is W2NDG, Neil, with the OMARC Sunday Night Science and Technology Net. This is a weekly net, a discussion of ham radio operators, some affiliated with the Overlook Mountain Amateur Radio Club, or OMARC. You do not need to be a member of OMARC to participate in the net. You just have to have a desire to talk about science and technology and all related things. Subjects here are not always necessarily related to ham radio, but can be. Tonight, we're going to do an open night, open topic. I'll let the listeners, as they check in, once we start going around from person to person, we'll take the rounds right away instead of my usual monologue or opening discussion. And I'll let the check-ins drive the net tonight. So, and I apologize to Jim, my sidekick. I'm just seeing your email now. It was an extremely busy day. But nothing in particular that I've picked. I'm going to pull my paperwork out and take a look at past notes, but we'll just see what everybody wants to talk about tonight. So let me throw it over to Jim for his check-in. K2BHM, come down. Okay, Jim might be tied up, so I think what we'll do is we'll take check-ins, and then I'll check to see if he's here later. This is W2NDG on the OMARC Sunday Night Science and Technology Net, taking check-ins now. Please check in with your call sign, your name, and your location.
W2RWS, Rob. My place.
Ball, KD2IWC. Good ball. This is
November 2, Foxtrot, Zulu, Charlie, Tom in Fishkill.
Here is KD2GGF, Matt in Kerhonkson.
Okay. I was kind of expecting a light night tonight. A lot of people doing all sorts of things today. I know I was. Had a really busy day today. But is there anybody else who would like to check into the Sunday Night Net?
This is KD2BAH, Jim in Poughkeepsie.
All right. I thought I heard someone after Jim there. There was a brief carrier. All right. And let's just check for other Jim again. K2BHM, are you around? All right, that's fine. Jim might have gotten tied up. I hope everything's all right. And what we'll do is we'll go around the 5 people who checked in and let me know what you're curious about, what you'd like to ask questions about, what you'd like to talk about. We can have multiple topics. It's fine. I know one thing I'll mention is I was hearing that 10 meters was kind of open today. I didn't have a chance to play with it, but I do have 10 meter capability in the car now, at least good working 10 meter capability, which I didn't before. So it should get interesting. Other than that, my mind was totally on lawn and garden tools and yard work today. So somebody put me in a direction. So let's start with Rob, W2RWS. How you doing tonight?
Yeah, good evening. Good evening, everybody. I was doing yard work as well. It's a fantastic day. Not hot at all. I guess I'm still monkeying around with the SDR play. The DX seems to be what I'm gravitating to because it's got multiple antennas, which I thought was kind of cool. The Duo is another $100, and I don't think I need to watch two different bands at the same time. And I guess you were saying this thing takes Tool, Uno, which is the software. Dave loaned me something called the ThumbNet, which is about 4 or 5 years old, and I'm not sure what software that takes. It looks like it's SDR Sharp, which is the pound sign. I'm still kind of fixated on this, and if you want to pick up a conversation on that, that's where my head's at the moment.
Okay, and we can definitely talk about SDR a bit. Like I said, I'm going to throw it around. I'm trying to multitask and skimming through Jim's email that he sent me earlier, and I'm embarrassed to say I probably should have seen this, but I was just focused on so many other things. But Jim said he might be a little late, so that's fine. That's all right. In fact, I may actually ask him to be the lead next Sunday. So. And I'm not familiar with the dongle that he loaned you. There's so many of them. But what is it again? I'll look it up.
Yeah, it's called the ThumbNet, ThumbNet. And I think it takes SDR Sharp. And I was wondering what the difference was with the softwares. I'm not sure what AirSpy runs. But I'm leaning toward the RSP because of the unlimited band monitoring.
A lot of these dongles use multiple software. I think the ThumbNet was one of the ones that was distributed to satellite enthusiasts. There was a lot. All this started, at least the RTL SDR dongle part of it, with a USB stick called the FunCube USB stick, and it was using very similar chipset to these European digital TV dongles, and that's where somebody got the idea to make this work the way we're using it now. So anyway, yeah, we can definitely do a deeper dive on that. And, if not, if we go in a different direction, I'll hang out and we can talk about that afterwards, either way. All right, so let me go on to Paul, KD2IWC. How you doing this evening, Paul?
Good evening, Neil, and all my OMARC friends. Long day for me. Running a chainsaw and a log splitter all day. Got quite a bit done. Kind of a public service announcement is that I was in P&T's on Saturday, and he got in several boxes full of ham radio gear. And from what I saw, there was a lot of 2-meter stuff in there, as well as other items. So, early ham gets the radio, so to say. So, you guys, if you're interested, it's worth checking out. Back to you. And as far as technology is concerned, at the moment I'm kind of too tired to really care. But I'm going to enjoy the night anyway.
That's fine, Paul. And yeah, I've seen P&T get stuff in a couple of times. That might warrant a visit tomorrow. Run up there midday, depending on what happens with one of the deliveries I'm expecting tomorrow. So, yeah, a day working in the yard kind of focuses your brain on other things. It's like I could definitely have a long discussion on pruning blackberry canes or some of the more interesting weeds that I found growing today. But I get it, believe me. Yeah, once I got into that mode, it started getting too late, and I realized that I still had to run and do my shopping. So I kind of ran out of time today. But I did make the net right when it started. And we are live on video, by the way. I didn't post a link, but I'm at least recording. And although I'm not particularly presentable tonight, I look like I've been working in the yard all day. I think just having a recording of everything is always a good idea. So in case something interesting happens tonight. All right. So on to Tom into FCC. Tom, how are you doing tonight?
WU2NDG in the group, and to FCC. Doing well. I, too, was out there doing yard work. Wife cleaned out some more flower beds, so I had to move a bunch of leaves out. After last week's discussion, I pulled out some raspberry Pis, so they're sitting there waiting for me to play with. Got to get an SD card and put the OS on there, but came on my radar. And my thoughts are about the sunspot cycle. I did hear that 10 meters is open, but I did not get to hear much. But tuning around, I really didn't hear much of what's going on the bands. 80 meters was kind of weird this morning, but I remember back in, I think it was 88, around that time, when 10 meters was crazy. I had a 10-meter radio in the car, and I was working all over the country and some European stations. And looking forward to 10 meters returning to that level. But sunspots don't quite seem to be there yet, so I'm anticipating. That's what I got for tonight. So then to FCC back to that.
All right. Sorry for the short delay. I was just posting the link on the OMARC site, or OMARC Facebook page, that we are live. So, yeah, I'm trying to, as I go through stuff, sort a little bit. And one of the things that I keep running into is Raspberry Pi stuff. So I eventually put them all on like one shelf or in one of the cabinets down in the workshop. One of the things I do need to do when I finally get an inventory of all the Pi stuff I have is to start putting together some of these hotspots. I've ordered 3 hotspot boards, 2 of the little simplex ones with the cases, like the one I already have, which I don't think anybody is actually watching tonight, but for the people who are watching again, one of these things I'm holding up. And one duplex one, which I'm going to use. I have a bunch of Raspberry Pi 3s that aren't purposed right now, so I'll probably use one of those for the duplex one. Anyway, all right, on to Matt, KB2GGF. Matt, how are you doing tonight?
Good evening, Neil. Doing okay. Hope you are as well. Good evening, everybody. Hope you're all doing okay. Not much doing today, just taking care of some stuff around the house that needed to be done. Didn't play on the radio too much. Did tune around
10 meters on the hope that that was opening up a bit, but really didn't copy much of anything going on. So keep looking, I guess. But yeah, I'm interested in talking about 10 meters and also some SDR type stuff. So that's about it from me. This is Matt, KD2GGF, back to net.
All right. And hello, Jim. I see you checked in on the video. All right. And you're up next. KD2VAH. Jim, how are you doing tonight? And is there anything in particular you'd like to talk about?
Well, a couple of things honestly interest me. Obviously, grounding. I'm talking about radio grounding in your shack and where it should go. I do like the SDR. I have a SDR, I guess you'd call it a dongle you stick in your USB, but for the life of me, I could never get it to work right, so I'm sure it's something I'm doing. And, excuse me, let me turn that down. And obviously, I'd love to talk about 8-cap antennas. Either way, pick what you want.
That's fine. And Jim, you're great. It's pretty much almost any ham radio topic is good for you. And there's so many of them, you know. There's so many different directions we can go in. And that's probably one of the things that a lot of us really love about the hobby. It's got something for everybody. And some of us are into all of it. So no end to topics. All right. Let's put a call out and see if Jim has arrived. And we'll see if there's any more check-ins while we're at it too. But Jim, K2BHM, you back from your outing?
Hi, Neil. K2BHM here. Yep, I'm back. They had problems at the restaurant and screwed up the dessert and had to make it twice, so it kind of slowed things down. But anyhow, I came in about Rob talking about SDR dongles.
No, perfect. He was the first check-in. So, all right, you've heard the suggested topics so far. I don't know if you had anything that you wanted to throw in that direction. I'm perfectly fine talking about SDR and a couple of the subtopics, but if there's anything else. And yes, I did give a heads up earlier. So next weekend, Stormville weekend for us, we should be home, you know, way early enough for me to do the net, but I might throw the lead over to you and I'll be Ed McMahon next weekend.
Okay. Do I have to hack Poetry Clearinghouse?
Oh God, what would the modern equivalent of that be? No, you gotta sit in the back and go, hi-yo.
Okay, sounds like a plan. Anyhow, did you get my email earlier?
Yeah, as I was starting the net, and I apologize. I was very focused on everything outside today, and for some reason, it never even occurred to me to sit down and start folding through the email. But by the time I finished up, I realized that I had, you know, a few minutes to kind of clean myself up, get out to the grocery store, get back here, have a quick something to eat, and start the net. And I just about managed it.
Okay. So for those uninitiated, basically I wasn't sure what the topic was going to be tonight. I didn't know if Neil was going to go with open subject, bring up a topic like Dave does sometimes, or if he had a favorite to go on or whatever. So I guess we're passing it around and just like pasta, throw it against the wall, see what sticks.
Well, that's what I figured. It works for Dave. Dave usually has a topic in the back of his head, but he goes around first, and sometimes a suggested topic takes over, which is fine because then it's usually something that everybody's into and everybody wants to talk about. So right now, our top one is SDR. Matt brought up also 10 meters, just talking about 10 meters in general in SDR. Tom also said SDR was a good topic, but brought up Raspberry Pi. So Raspberry Pis do kind of tie in with SDR, with at least like the SDR and the Pi talk that I do. There's a connection there, which is much more useful than it used to be. So, and Jim pretty much wants to talk about everything. But he has a dongle that he's never gotten to work, and I can touch on that too. So, all right. I think we have a direction to go in, and let's see if there's any more check-ins. If you'd like to check into the OMARC Science and Technology Net, I am Neil, W2NDG, and please come now with your call sign, your name, and your location.
Comment, KWHS.
Go ahead.
RTL SDR. I bought one a couple years ago, played around with it a little bit, and didn't get very far with it. And then there was a program that came out that would let it look at the raw data off the Accurite, and I got that up and running, and works good. And that's my experience with SDR dongle. So that's a good topic. I'm willing to sit back and learn.
All right, that works. Let me give a little quick run through. Like I said, I did the SDR forum one year at Ham Radio University, and it was a lot of fun because instead of going in the direction the guy who used to run it did, he was getting more advanced with it. I decided instead to approach the basics and talk about what it actually is. Now, we're not going to get too far into that tonight. I think this is something maybe we'll save for one of the in-person meetings or one of the online presentations that we're planning on doing. But software-defined radio, when I got into it, one of the first things that I'll talk about is what the words actually mean. Let me drop. So radio is easy. And in fact, we'll probably have a night on radio. Everybody's like, well, I know what radio is, but start from the basics and then work our way through the spectrum, what's out there. But radio, we know what radio is. At least we think we know what radio is, but that's fine. Software-defined radio. So computers have gotten fast enough, microprocessors in general, that we can emulate the function of a radio in software. Now, we're getting to a point where more and more things can be virtual. If you've heard of virtual computers, there's a lot of virtual computing out there now where, you have a server that actually is running 10 servers simultaneously, all virtually. So you can make a computer perform the functions of another computer or of another device. One of the earliest things like this would have been musical instruments, synthesizers. Let me drop. We all know what that 80s synthesizer sounded like. You can kind of peg it and all of that music. But as time has gone on, computers are more able to mimic the sounds of real instruments. And as computers get more and more powerful, they can do stuff like this. So the components of a radio, a lot of them can be duplicated in software. And that's where we're going with this. So in a regular radio, you have an RF section, and you have processing, and you have a user interface. So in a crystal radio, the receiver that's actually taking the radio waves in is the antenna coil. Let me drop. The processor in a crystal radio, the thing that's turning those radio waves into a signal, is the diode. And the user interface is the tuning knob. And of course we have output, but it's a very, very basic representation. When we do software-defined radio, we have a small device that is actually receiving radio spectrum. And then it's being processed by a computer or a microprocessor. And the user interface now is your computer. You're using a mouse, keyboard, and viewing things on the screen. Once you take processing and move it into software, the options become vast. So your filtering options, your noise reduction options, your ability to play with things like bandwidth and shifting, and the visualization of all of those things is what makes SDR attractive to a lot of people. Now, we're talking about SDR with computers, but you can take that same process. You have the RF board, the processing part of it, which is the computer and the software, and then some sort of user interface and input-output. And you can put that all into one self-contained device. And you could call it the ICOM IC7300 or the Yaesu 991A, or there's a lot of them. A lot of the modern transceivers are basically self-contained SDR systems. Let me drop. But before ham radio went in that direction, or even before it was widely publicized that a lot of these radios were actually self-contained SDRs, our first view into this were several of the early devices. Tony Parks, a ham radio operator who designed one of the more famous SDR circuits, was one of the pioneers in that. And Tony used to sell, and still does sell some of them, a line of kits called Soft Rock. Excuse me. Trying to think of the name. And the Soft Rock came in a few different flavors. The basic Soft Rock SDR was just a crystal-controlled software-defined radio that would receive a certain number of kilohertz on either side of the crystal frequency. How many kilohertz kind of depended on your sound card. Let me drop. This is W2NDG on the OMARC Sunday Night Science and Technology Net. So if you had a sound card that could handle 96K sampling, then your signal would be 48K on each side of the crystal frequency, or a total of 96K that you could view at one time. And you were bound to that crystal frequency. But for a ham radio operator, having a receiver where you could get that waterfall display and that spectrum display, 48K on either side of a CW frequency, for example, was a huge thing. And people started building these things. Then the next step was he had one that was controlled by a frequency synthesizer. And that was able to receive the entire HF spectrum, and that's called the Soft Rock. Trying to think of the name of it. I can't think of the name of the in-between one, but he had one that received all of the HF bands, and he still makes that one, and also makes it in a couple of flavors. There's a VHF one that'll do 2 meters, and he makes one that'll receive the new VLF band down below the AM band. Then he came out with the RX-TX and I have one of those. And the RX-TX is capable of being a transceiver, usually on 2, 3, or 4 bands, depending on which model you pick. Another drop. I think the one I have is 40, 30, and 20, but I'm not sure. But he sold them in different splits. And more recently came out with one that operated on those VLF bands. Now, these are very low power devices. They put out about 1 watt of power, and you could use an amplifier with them. They require a sound card connection to your computer, and you must have 2 sound cards, one for transmitting, one for receiving. And the way these work is the receiver board captures what's called I and Q streams, which stands for in phase and quadrature. And we won't get into the theory of that because I don't really understand 100% how it works. But there was an oversimplified explanation that was given to me once, and I kind of like it. So if you think about the I and Q signals, which are streams coming out of this receiver board to be processed by a computer, the I and Q signals were thought of as X and Y coordinates. So you're taking an analog product, which is what radio is. Radio is analog. Even when we send a digital signal over it, we're still receiving that noise before we process it into something else. If you have that, imagine the X and Y on a graph, and you can connect those X and Y points with a diagonal line. So you're going to the right a certain amount of points and up a certain amount of points. That's your X and your Y. And if you connect those two, you get a triangle. Now, if we all remember and don't have any flashbacks or go into some sort of convulsion remembering your junior high and high school trigonometry, but the Pythagorean theorem tells us that we can figure out the length and the slope of that line that connects and closes the triangle by knowing the position of those X and Y points. So the theory is, and once again, this is incredibly oversimplified, that for any given point during that transmission, we can model the signal from those X and Y points, or the I and Q signal, and we can reproduce what was originally there. Now, what's cool is that, once again, we're sampling a certain amount of kilohertz of signal and to be processed. So those I and Q signals, which do sound just like noise, can actually be recorded and played back. And when you're playing them back, you can reprocess them again. So you could record an hour of, let's say, the 20-meter band, and then play it back a week later and tune different stations off of that sample. There was a type of camera that came out a number of years ago, which is kind of the photographic version of this. And I think it's called light field photography. Can somebody check me on that? All right. I'm not sure if anybody had heard of it, but I may have the name wrong. Basically, it was a camera that captured an image the same kind of way, where it captured everything that the lens was capable of seeing. And then you can go back, load that raw image, and reprocess it an infinite number of times to focus on different things in the field. So you can refocus it, you can change it, you can change the aperture, you can change all the different aspects of photography after the fact. And it's a neat idea, and I haven't really heard much about it again. But I kind of thought when I was reading about SDR for the first time that it was a similar idea. So the more basic and primitive ones have that link between the RF board and the computer, which is basically an audio link, and then it's reprocessing it. So that's what a lot of these early ones were. Let me drop. There are more sophisticated ways of doing this. And a lot of the times it's simply that the audio portion of the device is captured within the device. So the SoftRock RxTX, hundreds and hundreds and hundreds of them were sold. There was a project that came out soon after called the Peaberry SDR. It doesn't exist anymore, but exists in another form. The Peaberry was designed the same form factor as the SoftRock. It'll fit into the same case that was made for the SoftRock, but it included the audio hardware. So you had one USB connection to the computer, and that USB connection was for control and for bidirectional audio. Whereas with the SoftRock, you had two audio connections, input and output, and USB for control. So, and it was a lot to configure and a lot to get working correctly. Still interesting stuff. With the Peaberry, so they had a couple of jacks, extra jacks left, because you didn't have those input-output jacks anymore. So to keep that same form factor, they added a direct Morse code key jack and I believe an amplifier control jack. I'm trying to remember, but the project still exists as something called the Multus, M-U-L-T-U-S SDR, and it's now a 160 through 10 5-watt radio on a circuit board, about the size of 2 Raspberry Pis. I forget what it sells for, but it's a 5-watt all-band, all-mode SDR that only requires a USB connection to your computer. Pretty cool. Let me drop. There are very sophisticated software-defined radios. We'll say mid-range, high-range, mid-range receivers. What Rob is talking about, things like the SDR Play, the AirSpy. There's a number of receivers in that category. I have a Japanese one called the Soft 66, which is a little quirky, but it works well. It's similar to some of those. I also have an SDR Play RSP-1A. So all those fall into kind of that category. Then you start getting into higher end, and a lot of those are transceivers. And you have things like the Flex radios, a whole line of software-defined radio-based products. The newer Elecraft products are SDR-based. And of course, some of the higher-end ICOM, Yaesu products that we talk about and we use. So then there's ultra and professional SDR equipment that they use in science. And I won't get into all those. I don't know quite as much about it, but there is a really interesting new occurrence that we've seen. Let me drop. W2NDG on the OMARC, Sunday Night Science and Technology Night, talking about SDR. Quantum computing is a whole new field and a major step forward in computing. I don't understand it 100% myself. I know that the basic idea is that, all computers operate in a binary mode, binary language, basically millions of little switches that know 1 and 0, on and off. Quantum computing has more than 2 states, and quantum computers are capable of solving massive problems that regular computers would take hours and hours, sometimes days and days to solve. Somebody has used a quantum computer to create a software-defined radio, and it's still in its infancy. It might even just be theoretical at this point, but the idea would be an SDR that was capable of receiving the entire radio spectrum from 10 kilohertz to 2 gigahertz or more at the same time, all at once. So you could technically, with enough storage, record the entire radio spectrum for an hour or two, or however much storage you could deal with and then go back and historically tune around on it later. Really can't wait to see that technology. So let's go in the other direction. A number of years ago, I started talking about this. There was a product that came out called the FunCube dongle. It was part of a satellite program, and it was sold so you could monitor this little CubeSat. It was also useful. You could do other things on it, mostly in the VHF and UHF frequency ranges. Right about the time that the whole world was going into digital television. Now, as you know, the US went in a completely different direction than a lot of the rest of the world. And a lot of the rest of the world picked a format that was very simple to emulate using essentially little SDR devices. So in Europe, they started selling these little USB dongles about the size of a USB memory or hard drive, little USB storage stick that would hook up to an antenna and receive digital television. They won't work here, at least not for TV, but somebody figured out how to get these to work with SDR software and wrote drivers. And there's a process to get them installed and running. Very early on, it was a lot of hacking to get it to work, but it worked. They don't always have wonderful dynamic range. The low end of the receiving range is down around 30 megahertz, although that can be changed. We'll get into that later. But they were selling these things on eBay for anywhere from $12 to $30 or $40, depending on which one you bought. And they worked. I had a couple of the early ones. It was definitely fun to experiment with. And that's what Jim was talking about. He has one of those that he said doesn't work. The hobby has grown in that direction quite a bit. And I'll tell you where to go for information. The best website for these things is RTL-SDR. I think it's .org, and I will double check that. But RTL-SDR.org. No, that's probably .com. Live failure on the OMARC Science and Technology Net. Let's see. Yes, RTL-STR.com. And there's a lot of information on this site. So the two most important things you're going to get on here are, let me drop, where to get one of these things and set it up, and what you can do with them. And there's a lot of devices based on the technology that'll show up here too. Like I pulled the site up today, and there's something here called the Kraken SDR, which is a passive radar demonstration. And passive radar is just one of the many crazy things you can do with these. But you'll notice if you go to this site, RTL-SDR.com, they have a store, and they sell their own dongles, and they're great. They are better than the modified European TV ones. That's basically what they're doing. They're buying a basic European TV USB board, and they're sprucing it up. They're putting a TCXO, which is a temperature compensated crystal oscillator in it, so that they're much more stable on frequency. They're aligning them. They're putting a little heat spreader in there. It's because these things do get really hot when you use them. And they've added a little feature called direct sampling. And direct sampling lets you put the thing into a mode where you can go below 30 megahertz and receive HF signals on them. They're not as sensitive as the SDRs designed for HF, but with a good antenna, they work. And really neat toy. So the process of getting them to work is a little convoluted. So on Linux or on a Mac, It's just a lot of copying and pasting of commands. There's plenty of sites that'll walk you through the process on Linux. On a Mac, it's pretty much just installing one of the packages, either Cubic SDR or one of the other SDR packages that comes with the RTL SDR drivers. On Windows, it's software, and then the drivers come separately. And when you install the drivers, you have to use this piece of software, and the name escapes me at the moment, but it's in the instructions, that forces the particular driver that makes these things work. Because the default driver that comes up, Windows thinks it knows what the device is, and it's going to try to install the driver for it. And you don't want that driver. You need to fool Windows and force a different driver. And that's what this little piece of software does. Once you get all that installed, what you'll find out, and this I'm kind of addressing to Rob, you can use whatever software you want as long as it supports that particular SDR. So the one you're talking about, chances are it's similar to all these RTL SDR dongles. It'll work with SDR Sharp. It'll work with WinRadio. It'll work with the SDR console. It'll work with Cubic SDR. It'll work with Lin SDR, or Lin Radio, excuse me, LIN Radio. There's so much software that'll work with these things in the Windows world. So you kind of have your choice. I don't know about the one that comes with the RSPs, the SDR Play devices. I don't know if that software will work on everything else or not. I haven't tried it. So, but lots of software. Another drop. You can do more than just receive with these. The airline industry went into a different type of tracking method that eliminates a lot of the radar that they were using and tower traffic. And what it does is it uses the special transponder on the aircraft, and it's called ADSB. And it's a way of tracking aircraft in your airspace using radio signals on a specific frequency, and I don't know the frequency offhand, but it is within the range of these RTL SDR dongles. And just an ordinary antenna will pick up these signals, but if you want to get into this, you can buy a special antenna that will pick up much better. And what's neat is when you set this up, and it starts feeding the signals into software, depending on which package you get, you can bring up a map on your screen that'll show you every airplane in the air over where you are. And I know the software that I used to play with would put the flight number on the plane graphically on the map. And if you clicked on it, it would tell you the airline, where the flight was coming from, where it's going, when it took off, when it's supposed to land, how fast it's going, what altitude it's at, yada, yada, yada. It doesn't seem like something that would be legal or something that we should be able to do, but it is an open system and anybody can monitor it. Let me drop. W2NDG on the OMARC Science and Technology Net. Any of these SDRs, so the AirSpy, well, I'm trying to remember if the AirSpy has one that goes up to a high enough frequency, but the SDR Plays definitely, I know they do, can also be used for the same purposes. The maritime industry also has the same thing, similar thing with tracking that you can tune into and do the same thing. Passive radar is crazy. It uses the theory that large objects in the air above you reflect radio waves. There are radio waves in the air everywhere. You have FM radio stations, you have police and fire towers, you have repeaters, you have all sorts of radio waves flying around the air. And passive radar says that when there is an object in the air, those radio waves are going to behave differently. So passive radar is a way of processing that information to tell you if there is something in the air in your airspace. It's pretty wild. I haven't played with it yet. There's another use that uses 4 simultaneous SDR receivers with 4 antennas at very specific locations around a circle or a square, so to speak. It might actually be 5 or 6 of them. I can't remember. That is a way of doing direction finding, similar to the Doppler units that professional transmitter hunters use, but it's using software-defined radio instead, and particularly the RTL SDR technology. So there's so much you can do with this stuff, and so many pieces of software, and so far that you can go with it. It's definitely one of the more fascinating parts of ham radio. And I do have one more thing to add real quick before we go around, but let me drop. Thursday night, I think on Thursday night's net when Dave was talking, we started on a similar topic. Somebody brought up the Lime SDR, and then I've heard somebody else talk about the Hack RF. Both of these devices fall into another category, which I'll call the experimenter's SDR. These are devices that can transmit and receive. They transmit at extremely low levels, milliwatts. And you could say, well, I could amplify that and use it as an exciter, in a transmitter or a transceiver. But the thing with these devices is they're not particularly filtered. They're experimenters devices. They're for generating frequencies and doing spectrum monitoring. They're not really processed and filtered to the point where they're good for what we do, but they can be. And there was another one out there called the Red Pitaya, which was available in all different forms with accessories mounted in a box. And one of them was a ham radio version that came with the proper filtering and amplification. So this is a huge part of ham radio. It's one of the reasons why I got involved, because it marries my 2 hobbies, radio and computers. But I'm going to throw it to Jim for comment, and then we'll go around. This is W2NDG. Jim, K2BHM. You still have ears, or did I talk them off?
Thanks, Bill. Oh, I got so many questions. Let me back up a little bit and follow radio through its process and kind of bring some people up to speed on something so that they understand my question. We started with the crystal radio, where you went and wrapped some wire around the Quaker Oats cereal carton and put a capacitor on it, and then you were tuning it with that particular tank circuit, and it was very difficult to disseminate between neighboring circuitry, or neighboring signals, I should say. Very little separation. And then they got a little better with putting active devices in tubes, and regenerative, where you took some feedback and boosted the gain up so you could have a little bit more gain and selectivity. And then we got into the super heterodyne, where you would convert it to a different frequency and get a little more selectivity, the 455 KCIS or the 10.7 IFs, and then dual conversion and so forth. Let me drop a second. So all these different techniques to narrow down the response and reject adjacent signals, so that you could listen to the station that you wanted to. And then once you got that signal out, then you would send it to a diode for AM detection, or a discriminator for FM, or put in some filtering and a DFO for upper or lower side band, whatever. After that point, you figured out what you were going to do, and deciphered it and sent it on to audio and out there. So my understanding is the SDRs just take the RF in and convert it from analog to to digital and spit it out to the computer. Is there some sort of filtering in there to narrow it down so that you're not looking at digital signals from DC to light? You really need to narrow things down so you don't have all this processing to do. I understand where the software could very easily differentiate between AM and FM or sideband or whatever in a narrow band. But you can't be looking at 10, 20, 40 meters, 80 meters all at the same time without a lot of processing. So how do they do that? How do they narrow it down? Any idea, or is that another topic? KGBHM.
Well, my understanding is that there's two steps here. One is the actual receiving of the radio spectrum, and different types of SDRs are capable of picking up more spectrum at once. You can look at, I know Rob was talking about one of the SDR play models was capable of looking at, I think, almost 10 megahertz of spectrum at once. Rob, do you remember what that number was?
Yes, it was 10, and the tool does 2 megahertz.
Yeah, so in that case, it's you're getting that stream, and you can set up a waterfall so you could look at that much at once. But you're only interacting with what you're tuning. Does that make sense? So you're looking at the spectrum, which is one part of the process, and then you're tuning in specific parts of it. And some of these have multiple tuners, which is interesting. I know when I'm using Cubic SDR, sometimes I forget that there's a certain way of clicking on it and using it where you start setting up multiple tuners, and I'll hear the fan on my computer really kick into gear and start ramping up when I have too many of them running, and I forget. But I think it's 2 steps there. It's what you're actually able to stream and watch in the waterfall and record for later processing, and then the actual processing of the frequency you're tuning in.
See if I got it. Okay, so basically, if you start off with a PLL VCO to set up a reference frequency, and your A to D has a certain bandwidth, then you can reference that VCO and go a certain spectrum one side or the other depending on the bandwidth of your A to D converter.
That's how I understand it. And once again, an oversimplification, I'm sure. And something I need to learn more about the theory on. So I apologize to the loss of video to the people watching, but I needed to cover the camera for a brief moment. Once again, that is how I understand it.
Okay, so the AC converter determines the bandwidth that you're going to cover, and then you've got a VCO to set the center frequency.
Yes. So, I mean, when you think about it, the ones that are all self-contained, that's basically what's going on, right?
I don't know. I just plugged it in and tried to load the software. Anyhow, light field cameras. They're available on Amazon for $189, and it looks like it's very similar to the technology used early on for laser holograms. Interesting.
Yeah, we all remember reading about that, being able to refocus an out-of-focus picture. But yeah, it's a cool idea. I wouldn't mind playing with it myself. For some reason, never really heard much more about it. I don't know. My guess is that it sounds amazing, but in practical use, maybe it looks unnatural or something to that effect. And I know some people, feel that SDR is the same way, that the signals sound processed. Personally, I don't really see that or hear that. And very early on, I can remember when I used to read the Crutchfield catalog. A couple of the Blaupunkt and Alpine radios that were very high tech at the time talked about receiving the signal and converting it to a digital signal so that processing could be done in the digital realm and then converting it back to analog. And I didn't even realize, what I was reading about was the beginnings of this. Now, DSP is not SDR, but they are related. And it's that technology that allows us to have a $25 handheld dual band radio with a digital display, or a Baofeng. And we have lots of radios. I don't have one next to me, but there's lots of shortwave radios you can buy, little portable shortwave radios by companies like Texsun that use this DSP technology, basically radio on a chip. And you can buy a demo board from DigiKey or one of these other companies that uses one of the SI series DSP chips. And with a very small handful of components and this chip, you can create a multiband radio that picks up long wave, medium wave, the shortwave bands from 1.7 megahertz up to 30 megahertz. And then they usually also have the FM broadcast band and sometimes weather monitoring as well. And this is the radio on a chip. And there's very little needed to make the complete radio. This is where it's gone, and a lot of this is very similar to what we're talking about. So these processors are fast enough that we can make this stuff work now. The noise reduction and filtering and processing is quite amazing. So anyway, let's go over to Rob, RWS. I'm not sure what got cut off at the end there.
Things were quite amazing.
All right. I only lost a few seconds. I wanted to go over to Rob, RWS, for comment, but actually, let's see if there's anybody else who wants to check in first. This is the OMARC Sunday Night Science and Technology Net, and we've been rambling on and on about SDR. So if you do want to check in, come now with your call sign, your name, and your location. All right. So, Rob, I throw it to you for comment and further questions.
Well, thanks. Just looking at the SDR Plays lineup, it asked me to select the radio and then the computer operating software, and I said Mac, and it uses cubic SDR. So that's kind of cool that I can use my Mac. Now, going out back to the Multis, that's $250. Now, does that give me a waterfall display similar to the RS, whatever it is, and then also broadcast at 5 watts? Because for an extra $100, I would get a radio plus a waterfall and double my capacity of the SDR play.
Well, the Multis is basically an HF rig. And I'm not sure where the developer is with his software. He was the last I was following the project, he was working on adding the waterfall display. And I also don't know if it works with other software. So there are a couple other packages that support transmitting. WinRadio is one of them. And I'm not sure what his supports. I thought, because it kind of evolved out of the soft rock, that Win Radio was one of the things that was supported. But you'd have to check on that. It's not really the same kind of device as something like the SDR Play, because it really is a 160 through 10 transceiver. It doesn't really do any more than that. But it's just a really cool proof of concept, and it is a kit. It does require assembly. He sends you a board with all the surface mount components on it, but you've got to hand wind some toroids and install a couple other through-hole parts. I think he has a build service, though. He will build it for you for a fee. But it is definitely neat if you want to get into SDR radio and also have a little capable QRP rig at the same time. He was also selling, but I don't think it's available anymore, a self-contained controller box that you could mount the whole thing into with a self-contained computer and display, and use it as just a regular portable QRP rig. So just a neat one to look at. But no, not definitely not going to do the same thing you're looking to do.
So I'm just leaning toward the RSPDX for $190 or something. Has several antennas on it. I can use my Mac next to my radio to do a waterfall of any frequency I desire, which is kind of cool. I want to use the computer more for reference. I can go to different websites to see what the band conditions are, who's on, what bands are hot, that sort of thing. And I thought, gee, this might just add to my flexibility. Not to change the subject, but I was just looking at another project that I was going to do on 10 meters, which was a modification. I bought a MFJ gizmo where you can screw two CB whip antennas. I have two 102-inch antennas and make a dipole. And then I thought, if I can go from CB, which is 11 meters, which is 102 inches, to 98 inches and cut off about 4 inches, I should get a good SWR on a cheap antenna out of two steel whips for 10 meters. I had the 10 meter mod done on my amplifier, so I'm ready to rock and roll with some high output.
Well, it definitely can be done. And what you're talking about is really, there is something out there called a buddy pole dipole, where you take the buddy pole antennas and screw two of them together into a dipole configuration. So that's something that's out there. Yeah, and SDR Uno is the Windows software that they offer, and they're still using Cubic as their main package on the Mac and on Linux, but they are promising a version of Uno for both Mac and Linux, which will be really cool because it is a great package. So, and as I said, there's other stuff that supports it too. Definitely, you can run other software, but I think you're looking in the right direction. You might also want to pick up one of those MFJ automatic antenna switches, so you can use it on the same antenna as your HF rig, and it will automatically block it when you transmit, so you don't blow the thing up. But then you can have that giant waterfall display for your HF radio. Cool stuff. And then you don't have to hack your radio for the IF output like we were also talking about. I'll throw it back to you for a quick comment, and then we'll continue around.
No, that's cool. I'm getting closer to making a decision. Perhaps I will download Uno and use that older device. What made that specific for satellites? Just because it was UHF, VHF? I'm not quite sure of that thumb drive thing.
Yeah, it was just the frequency range and the fact that it was a cheap way to get into that hobby, which was the whole idea of the FunCube dongle, which wasn't all that cheap, but it was cheaper than buying a couple $1,000 satellite receiver. So anyway, yep, that's you're heading in the right direction. So, and you have to let me know if Uno works with that thing. I wasn't sure what other devices it supported. KD2IWC, Paul, anything you'd like to throw into the SDR talk? We may have lost Paul. I may have put him to sleep, and I apologize. I do have that effect on people. But let's see if he's there. I know he was working hard in the yard today, so Paul may have gone to bed early. Paul, are you there?
I'm still here, thank you. But I've actually I'm sleeping as I'm sitting here and talking, so I'm just going to listen out. Back to the net, thank you.
Yeah, I know that's dangerous for me. I've been on a couple of nets when I'm really, really tired, and I start saying some pretty wacky things. All right, that's fine. Tom, N2FCC, comment and direction.
N2FCC. Yeah, SDR is really fascinating. You know, in the earlier days of radio, you know, crystal controls and tubes, and that's what I started out with. And you know, you sort of grasp the analog concepts. Then the concept that now, like you say, with the technology advancing to the point where you know, an ADC and put into a computer, and you can do so many different things once you get it into the computer. You know, you can manipulate bits. So it's interesting to see how the technology is advanced and the capabilities people have now with relatively cheap stuff. And you know, like you said, the Bofang radios. You know, how do you manufacture a $25 HT, dual band HT or whatever? So it's pretty wild. I haven't really got into it. My son got one of the early hack sort of SDRs years ago. He's a busy guy. He jumps from one project to another. But I never really, got into SDR. But it's certainly interesting stuff to learn about. That's what FCC back to that.
All right, Tom. And you mentioned Raspberry Pis earlier, and I said I would tie that in. In the early Raspberry Pi days with SDR, we didn't have enough computing power to actually run SDR on a Raspberry Pi. But what we could do is set up remote SDR. And I had this running at my own house. And basically, you took a Raspberry Pi and one of these dongles, and you streamed the I and Q signal, somewhat processed from SDR Sharp. You streamed it out of the Raspberry Pi using some basic RTL SDR software and connected over a network with SDR Sharp to your Raspberry Pi and dongle, and could process remotely. So it was a way of having a remote monitoring station, basically, that you could tune to any frequency. It was a neat idea, and it worked. It was good if you were wanting to receive something in a location where you really couldn't get a reliable radio or antenna up. From the later Pi 3s and the Pi 4 on, you can actually do SDR on a Pi, especially with the 4. It works. You can actually get the display going, and you can set up some neat stuff with these little touchscreen devices and such. So it does work. Anyway, cool. Matt, KB2GGF, your thoughts here?
Hello. I'm thinking a couple things about SDR. There certainly is a wide variety of them available now. Pretty amazing. And anecdotally, I seem to be hearing more QRP stations, both voice and CW on HS, and I'm wondering if SDR is taking that trend off a bit.
Indirectly, with some of the radios, yes, because there are a number of really good, inexpensive SDR based radios right now. Xiegu, for example, Chinese radio company, all of their line is SDR now, even their cheap quad band QRP rig, which is the G1M. It replaced a model called the X1M, which wasn't SDR based, but the G1M is, and the G90 is, and the X5105 is. There's the RS 918, 928, and 978 trio, sold under a number of different brands. They are Chinese copies of something called the Micro HF SDR, a radio that was developed by M0NKA out of England. He opened his project up, and the Chinese copied it, and they sell that radio for anywhere from $350 to $650, depending on the version you buy. And most of these are 5 to 10 watt radios. And there's plenty of other ones that have come out that are, SDR based. It makes sense. The new ICOM 705 is, it's a much easier way to get what you want. And it's also an easier way to make the radio reconfigurable and updatable, because if it's just software, it can be changed. But there's been a lot more interest in QRP, I think, lately, because there's so many good, inexpensive QRP rigs out there. And also the maker community in ham radio has really been flying. And you could buy a radio from India called the Micro BidX for a little over $200, which they say it's a kit. There's no soldering, really. You're basically just plugging a bunch of boards together, installing the thing into a case, and plugging it in and using it. And that's a 80 through 10 HF rig for about $230 odd. 5 watts again. So Hans Summers, creator of the QCX Mini that I did a lot of talking about and showing on my Wednesday night makers class, is also releasing a multi-band SDR radio. He's been working on it for years. It'll probably be another year or two before we see it. But in that case, too, you're talking about an under $200 multi-band radio that'll do, I think, 5 or 10 watts. Sorry, almost timed it out again, but hopefully that answers your question. But yeah, as time goes on, more and more of these rigs will be SDR based. So, and as the integration ramps up, that's something we talked about with Raspberry Pi last weekend. The cost goes down. Less components, more mass production, less cost, because this technology is used for more than just ham radio. W2NDG, back to you, Tom. Or Matt, I'm sorry. My mouse was covering up the bottom part of the list.
That's okay. I share a lot of the same letters with Tom. It's really fascinating what's going on with it. I'm really into it because they're small and cheap, and they work really well. I have a Xiegu G1M, and the receiver on it is just so good. I just enjoy tuning around the bands so much. So I'm quite happy with that. Other micro questions going on, but I'll save that for another time. So back to Ned. Thank you.
All right. This is W2NDG on the Sunday Night Science and Technology Net. All right. Jim, you still with us? KD2VAH.
I am, and it's honestly interesting. I plugged mine in, I'm trying to get it to work, and you're right about one thing. Lord, does this thing get hot.
Yeah, they do. I'm perfectly willing to give you a little assistance in getting it running. We just have to find some time to do that, but I'm still trying to remember the name of the program. I'll bring it up here. That comes up while you're doing the install. I remember it had a funny name. So, all right, Jim, K2BHM, how we doing?
Neil, K2BHM. Boy, you're bringing back some memories. When you were talking about the INQ signals. Back in the days of black and white TV, your signal, you had pulses that would sync the TV back to the transmitting signal, so that it would scan across the line and zip back, and scan across the next line and zip back, and scan across the next line in a very routine pattern. And the actual analog signal there was the intensity of the light on the screen at any particular point. And that was black and white. And then they decided to do color. Well, how are we going to do that? So they came up with this scheme of putting up a subcarrier, 3.579545 megahertz, and they would transmit the chrominance signal, which was companion to the luminance signal, or how bright the dot was. The chrominance signal would give you that vector that you were talking about to tell you what color that particular spot should be. So now, with the combination of the chrominance and luminance signal, you could tell whether the dot was supposed to be a certain brightness and whether it's supposed to be red, green, blue, yellow, orange, chartreuse, or whatever from two signals, multiplexing things together. So that followed very nicely into SDR, because now you can take the signal and determine whether it's AM, FM, single sideband, whatever, from the INQ signals. Very easy with the computer processing now. Pieces are starting to fit together. Thanks, K2BHM.
No, it is neat stuff, and I really enjoy it. And we can, you can tie it into every part of ham radio. Another part of this that I didn't mention are the web-based SDRs. The two most common ones are seen at websdr.org and KiwiSDR, I think .com. And I'll double check that. But this is where you have a software-defined radio that you put on the internet. And yes, it is KiwiSDR.com. If you look at either of these, there's a list of software-defined radios around the planet that you can load up in your browser. And your browser is loading the software that is doing the processing. It's pretty wild, and it does require a decently fast computer to operate well. Most modern computers are fine. Most modern phones will work with it now, which is pretty cool. So on the receiving end, it's just a web browser. You find a receiver, you play around with it. WebSDR.org, the software usually produces anywhere from a number of kilohertz to several megahertz of spectrum at one time. Most of the people who stream will stream more than one band. So they'll set it up to put more than one part of the spectrum up, but the only receiver on WebSDR.org that does all of HF at once is the developer's own receiver. And I have to tell you, if you really like to see how this stuff is put together or read about how people do things, read about his receiver and look at the building of it. He used to have some pretty high-res pictures of how he had to get the processor wired on his own custom-made board. I mean, just crazy stuff. But yeah, so WebSDR.org. If you contact him and tell him you want to run a receiver, he'll send you the software if he feels that your proposal is worth him paying attention to. And I can explain that. Let me drop. He doesn't offer the software to just anybody. And in his explanation, he says, we don't need another 40-meter receiver in Western Europe. If you look at the map, he had some overkill with certain ones. So he'd love to have people in the States put them up, at least in areas where he doesn't have any, which is most of, there's only a handful here. So if you wanted to do one of these, you could. It's Linux software. He gives you the install packages and tells you which operating systems it'll run on, but he also does have a version that'll work on the Pi now. It'll work with the RTL SDR dongle, also works with a number of other popular SDRs. Let me drop. KiwiSDR.com was developed by a ham in Europe as part of his, I think, PhD thesis. Pretty neat stuff. Again, using something called the Kiwi SDR board, which is designed to run on a Raspberry Pi-like single board computer called the BeagleBone. And the combination of those two devices produces a software-defined radio that can stream, I think, 100 kilohertz or lower, maybe 10 kilohertz. 10 kilohertz through 30 megahertz. I think it might actually top out at like 29.8 or 7 or something like that. But you get that whole spectrum and you can tune around on it. If you want to put one on the air, you can buy the project. It's, I think, around $300 for the whole package. But it also will work with the RTL SDR dongles, albeit just on usually a single band, and some other SDR hardware. I had one up and running for a while. I had a 6-meter receiver up on the Kiwi SDR site when I was on Long Island. So just using the RTL SDR dongle, and it worked. Just wanted to see if I could do it. So I'm going to look at it again sometime in the near future and see what other hardware he's supporting now. So, but those are the online ones, and there's a really cool thing you can do with them. W2NDG on the OMARC Sunday Night Science and Technology Net. You can use these to see what your own signal is doing. I mean, I use them for spotting sometimes, just to see how the bands are doing. There's locally here, there's a guy in Poquag that has one. There's a guy in West Milford, Pennsylvania that has one. It gives you an idea without, turning your radio on and doing all kinds of things, just what's going on with the bands. And you can tune around to different parts of the country and the world and see the same thing. But you can look for your own signal. And if you want to see what propagation is doing, you can check some of the sites like Whisper or Propagation Reporter and see what's going on in the air, and then pick a station in a place where you think your signals might be propagating to, and listen for yourself. I've done it. It's really cool, and especially if you don't do a lot of this, or you're pretty new to ham radio, it's pretty amazing to be tuned into like a station in the Czech Republic and hearing your own voice coming through the waterfall. So, a lot of fun. All right, let's pause for any late check-ins. This will be the last chance to check in. This is W2NDG on the Sunday Night OMARC Science and Technology Net. Come now with your call sign, your name, and your location. All right. We won't go roundtable again unless somebody brings up something we need to do that with, but it's 9:30. So I'm going to open it up just to anybody else who has any further questions or comments on all of this. I think I would like to update my SDR presentation that I have, change a lot of the products, add some of the new technologies that have come out. What I would love to do once we're back to in-person meetings, some live demos of some of this stuff, like the ADSB airplane tracking. I'd really like to get into passive, passive radar. Just the idea of that always amazed me. And I might even buy one of these Kerberos or the other unit, the Kraken, that I was just talking about, because I think it would be just really cool to experiment with one of these. So YouTube is going to have so much of this, and you can look for any aspect of it. If you want a cheap entry into this technology to play with, rtl-sdr.com, go to their store, buy one of their dongles. Do not buy the dongle off of eBay from them, because it's not from them, it's a counterfeit. There's a whole bunch of them with their name on them out there that are not from them. But that is probably the best of the RTL SDR dongles. It won't cost you a lot of money, and it's a good way to get into this cheaply. If you want to spend a couple $100 just on a receiver, as I've been steering Rob towards the SDR Play models, they do HF and UHF and VHF, and they do it well. And you can play with the software. Steve, K2GOG, did a whole thing on a SDR package, and I can't think of the name of it. It's a huge piece of software written for Windows, and it's also written for Linux. You can make it run on a Mac, which I did. And it has a lot of built-ins, things that you would normally add on with software. Let me drop. SDR Angel, that's what it was. And what's interesting, it has a lot of the digital decoding built in. So you can decode digital signals, PSK31, RTTY, things like that, but it'll also decode digital audio. You can decode DMR. And I believe it'll do D-Star, but I'm not sure. I know it does DMR and P25. I think it'll do Fusion, because DMR and Fusion are very similar in how they're constructed. All this stuff built into it. Jim talked about the RTL 433 software, being able to look at the streams coming out of your weather monitor. That's not the only thing that's talking on 433. Your tire pressure sensors are chattering constantly. There's a lot of chatter going on around your house. Your electric and gas meters are putting out RF and saying various things here and there. And there's all sorts of other devices out there that you can monitor using one of these dongles. Let me drop. I have also successfully streamed HD radio on one of these dongles and decoded it on my computer. HD radio is the IBOC, or in-band on-channel digital radio, that a lot of our FM stations use. If you look at the FM stations like WPDH in Poughkeepsie, that's one of the ones that has it. If you look at their signal on a waterfall, you'll see these solid bars left and right of the main modulation. That's the digital part of the signal, and you can decode that. What's cool about something like the PDH signal is it's multi-channel. This is a command line piece of software. You run it in Linux or on a Mac, and punching some commands up, you can listen to the different streams. There's 3, possibly 4 different radio streams in that digital signal. So stuff like that. You can do all of that with this. This is what SDR radio is good for. So all of these different things. And if you haven't played with it yet, a whole new world of ham radio to look into. This is W2NDG. Anybody who would like to comment further or ask more questions, just throw your call sign out and your name, and we'll take it from there. Well, that can be good or bad. The good would be that I've covered the subject so well that nobody has any questions anymore. But what's probably going on is I've put you all to sleep, and I apologize. But you won't hear that till you watch the video. But anyway, I'm going to close the net. Anybody who wants to hang out and chat, you're welcome to. But this has been the OMARC Sunday Night Science and Technology Net. Let me throw it over to Jim for a close. You have any closing statements, Jim?
Thanks, Neil. No, I haven't really played around with SDR to any extent. Just a little fiddling around and had other things to do, but that really opened up some light today. Made some associations with some other technologies and how it one thing led to another and so forth, and put some pieces together and make a little more sense now. Thanks. That's pretty much it. And I'd like to also say thanks to everybody that participated tonight and threw their 2 cents into the ring and made it an enjoyable and productive conversation. K2BHM.
Well, thank you, Jim. And yes, thank you to everybody who checked in tonight. And thank you to all who are watching and those who are watching after the fact. Thank you for supporting the OMARC Science and Technology Net, which is brought to you by the Overlook Mountain Amateur Radio Club, or OMARC, which can be found at omarcclub.org on the internet, or on Facebook, the Overlook Mountain Amateur Radio Club on Facebook. We are a ham radio club located in the Hudson Valley. You do not need to be a member of the club to participate in our nets, but it's highly encouraged, and we welcome you. We're a fun group of people with a lot of activities, and obviously a lot of people in this club perfectly willing to teach and pass along their knowledge and their time. If you would like to find out more and join the club, you can go to the web on our website or check us out on our Facebook page. We have 2 nets every day at 8:35 in the morning. We have the 8:35 on the 805, which is run 5 days a week by Paul, AC2UQ, and also on Wednesdays by Rob, W2RWS, and on Sundays by Jed. And I need to write his call sign down because I can never remember it when I say that. At 6:30 every evening, we have a rotating group of OMARC members that host the 6:30 check-in net. Similar to the 8:35, it's just a bunch of hams getting in touch with each other and talking about what they did that day and what they're doing. Both of these nets came around during COVID to try to help us stay social and keep the ham community going, and also help us keep an eye both on our fellow hams and ourselves. Every Thursday night, Dave, K2GLV, hosts the Thursday night net. Dave usually picks a topic and go around and discuss a specific ham radio or ham radio related topic, but sometimes on the first round, the participants will identify another issue or problem that they're looking at discussing and having some focus on. Every Sunday night, myself, W2NDG, and Jim, K2BHM, host the Sunday night OMARC Science and Technology Net at 8 o'clock every Sunday night, also streaming on YouTube. We welcome you to come back next week. We welcome you to watch our videos, right now located at W2NDG Science and Technology on YouTube. That's W2NDG Science and Technology. We'll be back here next week at 8 o'clock. And this is W2NDG closing the net. Sorry, Jim, no grounding tonight.
That's okay. I actually been researching. I'm getting some braided cable. I'm getting prepared.
You're probably going to end up knowing more about it than I do. Being an apartment dweller and a rental guy for, almost the whole time I was a ham, I could never do much in the way of permanent installations. So grounding was never something I could deal with because, most landlords don't want you driving a 3 or 6 foot piece of metal into their yard. Also, if I mess up here and puncture something, it's my problem. If you mess up and puncture something at your landlord's place, it's still your problem, but it becomes their problem, and it also usually becomes an eviction letter. So I haven't dealt with that stuff yet.
Yeah, I hear that. Well, I've already invested into 3 more 8-foot copper pipes, and I've got to drive them in, and the final one will be right underneath the electric meter because whoever put it in 100 years ago literally